Thank you for joining the Resilient Cyber Show. My name is Chris Hughes, and today I'm joined by Henrik and Amod from Endor Labs. We'll be diving into the latest report they have, the 2025 State of Dependency Management. But for folks that don't know you gentlemen, as well as the team at Endor Labs, can you tell us a bit about yourself as well as a team? Maybe start with you, Amod.
Hey, Chris, thank you so much. Glad to be here. My name is Amod. I run the product and the design team at Endor. For those of you who don't know about Endor, we are a consolidated application security platform. We help our customers find and remediate supply chain risks, starting with, you know, security issues in your open source dependencies, security issues in your first-party code, any unsecure AI models that you might be using, MCP servers. Basically, our mission is to secure your code and everything that it depends on. And yeah, glad to be here and looking forward to the conversation.
Awesome. How about you, Henrik?
Hey, Chris. My name is Henrik Plate. I'm leading the security research team at Endor Labs, and kind of our tasks are to maintain our proprietary vulnerability database, look into zero-day research, finding new vulnerabilities, but we also look at malware and supply chain attacks, which are, hitting all of us these days quite a bit.
Yeah, definitely a rise. And I've covered the report last year in a deep dive on my own, and now, covered it this year for my audience. Can check that out on my website. But let's open up on the report here and dive into some of the findings. It kind of opens up discussing the overall impact and transformation that AI and LLMs are having on development. Some of the security implications of that, like AI generated code being vulnerable 25 to 75% of the time. And you guys go into some of the nuances of languages and prompt styles and things like that. And some of this is known in research and academia and industry and all those things. But you also state how AI coding tools tend to struggle with authentication and authorization. And I found that one particularly interesting, given that, the predominant way of incidents happening is often, credential compromise. If you look at like DBIR, for example, things like broken access control is still the top, risk in the OWASP top 10 that just came out last week. What do you guys think that infers for the future of AppSec when we see this kind of being a problem tied to the AI code generation?
Yeah, maybe I go first. And let me also take the opportunity to comment quickly on those numbers, right? You mentioned AI-generated code is insecure between 25 and 75% of the cases. I think it's noteworthy to say that these are very specific experimental setups, right? And just because you happen to find one where 75% of the generated code is secure, it doesn't mean it will be the same in your specific context. Those experiments differ wildly in terms of the languages they look at, how to assess whether the generated code is secure or not, and so forth. So, before, considering to go all in, check in your specific context whether AI generated code works or works not, right? Now, in terms of authentication and authorization issues, I think this is a class of vulnerabilities that is inherently difficult to spot, both by kind of AI-assisted code reviewers or as well as by the more classical SAST scanners, if you want. And I think the reason is that those, compared to other types of vulnerabilities like SQL injection or so, there is a lot of knowledge that is not necessarily contained in the code base itself. Again, taking the example of SQL injection, right? You would have the data sources, the data sinks, the SQL statements all in your source code. You still need to have this data flow analysis to be built and to be understood across several files. Not easy, but at least you have it all in the code and you can assess it by looking at the code in many of the cases. For authorization issues, you need to have more knowledge of the application, personas, use cases, scenarios, in order to understand whether a certain API endpoint or so requires authorization or permission checks, right? And that is more difficult. And that is why I think those AI assistants struggle both in generating this, but also in discovering related vulnerabilities. And that was now a long answer. Sorry if I went too
No, you're fine. No, you're fine. How about you, Amod? What do you think that kind of implies for AppSec as we move forward and people become, kind of inherently reliant on these tools to be more productive and produce more code, have higher code velocity, things like that. But as you all point out in the report, there's some, serious security implications as well.
Yeah, they are. They are. I agree with Henrik 100%. We are also hearing from our customers that as they rely more on these coding assistants, these sort of higher order issues have started to surface more and more. LLMs and coding assistants are as a human, when you code and when you cross a certain access boundary, you think twice about, is this operation allowed? Should I be doing that? And LLM, if it's possible to do it, will do it. Now, historically, we've used testing and integration to test the functional aspects of the application, not access control and business logic. So on the testing side also, it's hard to catch these types of issues when they creep in. Like Henrik was saying, rule-based testing is not the best way. Rule-based scanning is not the best way to catch them either. So it's easy for these type of issues to come in. It's becoming easier for them to come in, and harder for them to be spotted. So we hear from our customers, well, yes, we have these tools that can do rule-based pattern matching, but the value that they're getting from Endor Labs is we have these products where we can do security reviews during pull requests and catch these type of business logic issues, authorization issues. So we're hearing about that more and more.
Yeah, something I wanted to ask you that you both point out here is the challenge that this presents. Like there's a dichotomy of benefit of productivity, velocity, but also security concerns. And this is not necessarily a technical question, so I'm curious, like both from the researcher perspective and yourself on the product side, Amod, and the, working with customers and things like that. There seems to be and this is coming out in research and studies and so on, like an implicit trust that users have in these AI coding assistants, where they're kind of inherently trusting the output, despite what we're finding in the research, like the State of Dependency Management report and so on. How do we tackle that cultural challenge of getting them to understand like these tools are great, but there's some real risks and concerns, and we need to still do traditional security activities and more modern AI native security activities as well. Like how do we tackle that cultural side of things? Perhaps start with you on that one, Amod.
Yeah, I think cultural is the right way to tackle that. I think the first thing we have to do is make everyone realize that the code that's a pull request where the code is generated by an assistant is not the same as a pull request which has had the human eyes on it. So we need to start taking AI generated code as untrusted third-party input. So the same rigor that you'd apply to some code that somebody else wrote and is available on the internet, and you are not just going to copy paste this in your enterprise. Culturally, that's how you have to start to look at AI generated input. And therefore, everything else that comes from that, the rigor in scanning, the rigor in reviewing, the rigor in making sure that it passes your security guidelines, governance policies, that has to be applied even more thoroughly. So jump in, Henrik. I think you have some thoughts on this, but that's where I would start culturally. Start to look at AI generated code as third-party input, not as first-party code, even though it appears in first-party code.
Yeah. What it reminded me is, so I agree there has to be some cultural change. But one thing that we have noticed, and many have noticed, that it makes a lot of difference on how you prompt and how you use your code assistant, right? And so what is important to understand is the more specific you are in your prompts, the better the quality. We noticed this in the report itself, depending on kind of whether we prompted to use any version of a dependency, the latest version or a secure version, we noticed a difference in the quality of the version suggestions done by Cursor. And this applies to other areas as well, right? So be more specific in terms of which security controls you want to be implemented in the code you're about to generate. That, of course, requires a certain expertise from the developer. And the more senior developers, they will know what to prompt, what to include, how to sanitize input, and so forth. So that is a bit challenging, but I think this can be overcome by, especially in the context of enterprises, to make sure that all of these security requirements, both general best practices, but as well as company-specific requirements, end up in those prompts, and you can configure most of those code assistants to have them included by default, which relieves a bit the developer to include whatever in the prompt.
Yeah, I think just to add on to what Henrik's saying, the models behind these coding assistants are not oblivious to this fact, and so they are facilitating this more and more. Claude has different model. They can all consume markdown files that are part of your repositories. In fact, one of our customers was telling us that they have this practice, they have a monorepo, and they have this practice of seeding every layer of the monorepo with a markdown file that has coding guidelines. We also, I think, some time ago published around 40 prompts that will help make coding more secure by default. That's available on the website. But I think culturally, we should start treating these assistants as more of platforms. Don't trust the output. Don't trust the output blindly. Make sure your guidelines are in there. Make sure your security policies are in there and they're being followed.
Yeah, I had a question for you, Henrik, real quick, because I know you're on the research side, and I'm not a researcher, but I do nerd out on the research and publications myself. And I have published a blog on Endor's blog, a couple of weeks back, citing some research that showed it was interesting because it showed that as code is iteratively developed with these tools, even in the use case of security-centric prompting, it introduces new vulnerabilities. Like it's less when you use security-centric prompting, but it still is introducing new vulnerabilities. And it seemed kind of counterintuitive in that way, because we're saying, hey, the way you prompt matters, and we know that, right? And use security-centric prompting can make a difference. But in that research, it showed that even in the presence of security-centric prompting, there were still new vulnerabilities being introduced. So it seems like you're damned if you do and damned if you don't, a bit.
No, I would say it cannot be your only control, your only kind of defense, right? You will need to have those prompts, but you will also have all those other tools to be integrated at different moments in the life cycle. And I think one other outcome of the report is that on top of those prompts, if you include tools in the code generation process, be it kind of native generic tools that come built in with Cursor, or also MCP servers, they help a lot improve the quality of the generated code. I find this interesting because it kind of moves all the STA tools and SAS tools that we happen to know for quite some time and that run on CI/CD systems. We kind of shift them further left to the earliest point in time when code is conceived. Of course, this also doesn't mean we don't need to scan it any longer in later stages of the development lifecycle. Those checks and balances or checks still need to be there. But to put it short, I think this is another kind of ingredient to increase the code quality.
Yeah. I kind of walked away from that research thinking the same thing. Like, yes, this is a tool in the tool belt, but it's not a silver bullet, right? Like it's a defense in depth, kind of paradigm all over again, that you need to be using multiple different methodologies. And speaking of that, you guys in the report, you lay out what you call proactive and reactive mitigations, for using AI coding tools securely. I was hoping to kind of spend some time discussing, what a few of those are on each side and hear from you guys on that front. Either of you guys want to jump in first on that.
Yeah, I can take a stab at this first. So that's exactly right. Prompts are not going to be enough. They're going to generate better output, but they're not going to be enough. Another place where our customers have found a lot of success is in this concept of pair programmer. So if you think of AI assistants and coding assistants as, the way where the industry is right now, as junior developers, and they're getting better and they're becoming more and better at producing code. But if you pair that junior developer with an MCP server from a tool like Endor, then all of a sudden there is someone with the security oversight of what this tool is producing. As an example, if AI for some reason hallucinates and tries to pull in a dependency that doesn't exist, this MCP server can catch it and prompt the AI code generation engine to change that. If you have a policy that you don't want to introduce obviously you should have a policy like that, but if you have a policy like that in your prompt, you don't want to introduce any new critical CVEs in your code, this MCP server can catch if you're importing a version of a third-party dependency that has a critical CVE, and it can prompt the AI code generation with alternatives. Here are versions that have the same signature, or here are versions or different packages that do the same thing. So there are lots of examples like that across the board. If you're writing secrets in plain text, the tools that are available to these coding agents that can catch that in the moment, like Henrik said, when the code is conceived. So prompts are one way of doing it. You have your pair programmer concept with MCP servers as another check when the code is being produced. Then as it starts to go through the pipeline, pull request review, pull request scans, and so on. There are checks and balances at every stage.
Yeah.
Anything to add on there, Henrik?
Yeah, I mean, along the same lines, for me, in the report, what we meant with proactive would be, all the whistles and bells you consider during the code generation, during code conception. And again, MCP servers or tools more generally are a great way of putting all those existing tools and new tools into this early phases. And reactive refers to all the controls being applied once the code has been generated, is part of a pull request where you can do code reviews of the pull request in isolation, maybe also considering the history, but also then at later stages, whole program analysis and also dynamic approaches to testing an application in a runtime environment or so. This for me goes back to this very old chart, must be like 20, 30 years old, saying that the earlier you find the bugs, the cheaper and easier it is, and the later you find them, the more expensive it is. And that applies here in the same way.
Yeah, that's an interesting report. I'll send you a link after this, but some people debate the origins of the report. I know you'd like to probably geek out on that too. But you mentioned the runtime aspect. And I know Endor has some great partnerships with some runtime, kind of focused vendors too. So that's a great call out. And you mentioned you each have mentioned MCP, and I know a big part of the report, dived really deep on MCP. Its pervasiveness across the ecosystem, and there were some really critical findings there. When I read that, I forget the exact numbers, but it was like an overwhelming majority of the MCP servers that are available come from individuals rather than organizations. It feels like it's kind of, open source over again, in the sense that people are just inherently using things off the internet from individuals that they don't know whether they're secure. Like, what were some of the key findings when you guys dug into MCP that jumped out to each of you? Maybe start with you on that one, Henrik.
Yeah. Maybe first to comment on this, you have used the word pervasiveness in the ecosystem. I'm not sure. It's true, there was an incredible spike in the number of MCP servers being developed and published and listed on some of those web pages. And so I agree, once more, the open source community showed just how innovative they are in developing so much just in a short period of time after Anthropic published this MCP, I think in November last year. I think there was a single week. So overall, I think there are more than 10,000 or so MCP servers listed in those registries, in quotes. And I think a single week in March or so saw more than 1,000 MCP servers alone. So there is just incredible numbers. Now, I agree, we see many new MCP servers popping up like mushrooms. What we don't have numbers for is how many of them are used in reality. I think there the situation is much more blurry. I don't have numbers, at least off the top of my head. I don't know any report investigating this question. Right. That is now coming back to the kind of some of the key findings of the report. You're right. So most of them are developed by individuals, which is per se not bad, of course, right? We have this so many important open source components are developed and maintained by single contributors. The famous guy from Nebraska, all good. But some of the things that we have noticed is there are some uncertainties coming with the licenses, making it maybe more difficult to use such MCP servers in enterprise environments. We see also an increasing number of CVEs reported for those. And those reported CVEs, they are related to the fact that all those MCP servers, and that is one takeaway from the report, all those MCP servers make use of what we call sensitive APIs. They open files and read files on the system where they are running and where they are installed. They open operating system processes. They establish network connections, right? So these are the sensitive APIs, and the MCP servers heavily rely on them. And all of those come with vulnerabilities. And this is why we see an increased number of CVEs reported. We found a couple ourselves that we reported to the maintainers. So yeah, these are some of the issues that we are seeing here.
Anything to add on that one, Amod?
Yeah, I think Henrik covered it well. I think MCP servers are clearly a part of your supply chain now. And so all the risks that are traditionally been associated with any component of your supply chain, vulnerabilities, malware, CVEs, they're all there.
Yeah.
One thing I'll say that over the weekend I was playing with this, a local LLM running on my desktop, trying to book a reservation for a tennis court, and I was trying to download use an MCP server for Playwright, this library that can be used to control the browser. That's supposedly from Microsoft. But if you don't squint at it and just go download an MCP server for Playwright, there's about half a dozen of those that are not Microsoft. And so now, if you're not looking closely, one, you risk of downloading something that looks like it came from a certain company and is just going to sit in the background. But who knows? The second thing is, this is a evolving area. So not every company yet has their MCP server. All the tools that we use happily with their APIs don't have an MCP server, and individuals have filled in that gap, or have at least stepped in, assuming good intent to fill that gap. We have to be careful that you're grabbing an MCP server from company X. Does it really company X, or is it just something sitting on top of the APIs of company X?
Mhm.
So that's
Yeah.
another thing that I just wanted to point out.
Yeah, again, it's like it seems like the same challenges like you guys pointed out with open source. There's a broad supply chain, software
Yep.
concern. There's kind of typo squatting where people may like name something very similar to something that's available from a large provider like a Microsoft. And you guys each kind of hinted at this. It seems like MCP, much like AI, is kind of this double-edged sword, right? Where it can introduce novel risks and new attack vectors and things like that. But it also, as you said earlier in the conversation, it can really shift left security all the way to the IDE or to the point of development in agentic coding workflows. So any recommendations from the report, or even in practice from both of you, of how people can adopt MCP securely, or what they should be keeping in mind, as they look to use MCP to kind of modernize how they do software security?
So first of all, in terms of, I want to kind of confirm what Amod was saying earlier on. So in some sense, MCP servers are just like any other dependency that you have and you use during your software development process, right? One particular risk, before coming to your question, I wanted to highlight this out. There was an interesting malware just a couple of weeks ago, which showed a new risk, which I find worthwhile highlighting. Which is that it was basically a malicious package that once it was installed in your environment, it looked for the presence of AI code assistance in your system, in the system of the victim who installed this malicious package. And then it would just ask it, right, can you help me, dear AI code assistant, to harvest the credentials that are on this developer machine? So I think this is a new risk that comes with these agentic systems being deployed a little bit, mostly I would say by individuals and not so much by, according to company enterprise guidance and policies and so forth. So I think this is where there is a huge risk for enterprises controlling this new shadow AI IT popping up on all the individual developer laptops with MCP servers being installed and this code agent and so forth. Right. And then in terms of, and now back to your question, sorry for this little excursion here. What can we do in order to run those MCP servers more securely? I think there is a huge gap, honestly. Most of this is my feeling, is driven by individuals trying to innovate, experience and play with these new technologies. They run this locally mostly, and I don't think there is yet the kind of infrastructure that allows companies to run MCP servers in a secure way in, let's say, sandboxed environment on some dedicated systems in a company internal or whatever cloud, for example, or in a way that you can trace and track and audit the communications. These are kind of very important pieces that don't, I would say, are not mature yet. And this is where I think we need to, we will see a lot of things going on in the upcoming months and years.
Yeah, exactly. I agree. This is an evolving field. We have to apply the first principles of security here. It's an essential component of your supply chain. which means we have to be able to do an inventory just like we do for any third-party dependency. In a recent conversation with a customer, we were surprised to find that they were saying there are about 50 to 70 MCP servers running on a developer workstation in their company. And this is not a small company. So the security team has a general idea of which those are, but they don't know for sure. So starting with an inventory of what's out there, maybe even if you have an opinion on what should be used, maybe even start with a whitelist. These are the only allowed MCP servers that are out there. There aren't very good tools right now to do the opposite. If you have a blacklist, what do you do? Like, how do you stop it from a governance point of view across the board? There's some thought leadership there. Then for every MCP server, at least the ones that can cause damage, you need to give them the right access controlled authentication token. If you over provision the access to what we started the conversation with, then there's more trouble. So all of these first principles need to be applied to these MCPs that we have been applied to other parts of your supply chain ecosystem now.
Yeah, agreed. I think it's some of the fundamental challenges around visibility, governance, IAM, et cetera, are just now kind of spilling over into this new domain that's emerging. And speaking about evolution, two things. First, I agree with you, Henrik, about the agentic coding assistance being kind of a new attack vector on the developer endpoints, and that has broad supply chain concerns there. And we've seen vulnerabilities in some of these leading tools, that are being patched and reported pretty quickly, but still something to keep an eye on. And I'd be remiss if I didn't bring this up with you both. It's November 14th. Yesterday, news broke from Anthropic that they thwarted a cyber espionage, usage of their platform. I don't know if you each have seen this, but it's kind of cluttering everything I look at in terms of LinkedIn and so on. Like, it's all everyone's talking about. I'm curious you guys' thoughts if you had a chance to see that. What we should think of that. For me, it was I look at that and I see it's like an innovative use of AI from an attacker's perspective. We know development teams are using AI. It kind of reinforces to me that security should be looking to use this technology too. Developers are using it, attackers are using it, right? We should be looking to do the same, become competent and proficient in it, and it's the only way we're going to be able to keep up. And also, it's kind of an interesting paradigm in the sense that the way they laid it out, only the leading model providers are kind of in a real position to thwart this use of the technology, in that way, kind of the same way as, cloud service providers could thwart, nation states using their platforms for malicious activity. But yeah, I'm curious, what you each thought of it, and given that news just broke yesterday.
Well, I haven't had the time yet to look into this new example, but I guess it is similar to what Anthropic already plotted in August, right? Where kind of attackers used the tool suite coming with the Kali Linux distribution in order to kind of craft an end-to-end AI-guided or AI-led attack from the initial reconnaissance, finding the weaknesses, getting into the systems, moving laterally in the compromised systems up until the exfiltration of the data and the creation of custom ransom nodes that pop up on the victim's machine. That was already back in August, I think very eye-opening and very concerning. So for me, to some extent, this race between the attackers using technologies and we kind of the defenders using the same technologies keeps on at an accelerated pace in this AI times.
Yeah, couldn't agree more. I think this is a tool, and we need to think of this as a tool. It's not just a tool to generate malicious traffic and malicious attacks. It's also a tool to become more secure. And we at Endor are taking that view, and we are using this thoroughly in all parts of the ecosystem to make it better. An example that we talked about at the beginning of the call was there was a world where we used to use static rules to look at first-party code to find out patterns that were weak. There's a place for that, but that can be augmented significantly with AI tools looking for higher order security issues. We talked about authorization and business logic issues. Henrik talked about using security guidelines that were very hard to provide as an input to your static pattern-based matching, but AI tools are good at using that. Like you also said, Chris, the platforms are also doing it. In our experiments, we've recently found that we scan vulnerabilities a lot. We try to write exploits that verify whether the vulnerabilities have been fixed or not. Our CTO who was running this experiment was telling us that more recently he's found that the frontier models don't allow you to generate these exploits anymore, because they think that this is being going to be used for nefarious purposes. So 6 months ago, you could prompt a model to do whatever with a weakness. Now, if you don't put it within a certain guidelines and it's not obvious to the model that you're generating a test case rather than an actual attack, the model actually refuses to do it. So we'll see more and more of those guardrails come in. This is a very fast changing world. But yeah, I think we cannot just look at this as AI is not bad. It's how you use it, which makes it good or bad.
Agreed. Yeah, it's a tool. And what's interesting, if for folks that want to go check out that Anthropic report, it's about 13 pages or so, is they walk through exactly what Amod was saying. Like, they had guardrails in place. So what they did was they broke their activities into very discrete tasks, and they also prompted it from the perspective of, I'm a cybersecurity researcher or practitioner. Like they framed their activities in a way that the model would allow them to conduct these activities without being flagged as malicious activity. So really fascinating stuff on that. And then, and one other thing I want to touch on with you guys before we wrap up here is another key finding in the report was, that of package hallucinations and how the rates vary drastically, across languages and models and with and without tool use. And I wanted to, ask you both, like, what can be done based on that research to minimize package hallucinations? And then Amod, you talked about this a little bit earlier, tools like Endor Labs, to kind of mitigate risk, from package hallucinations as well. So curious to hear from you both on that one.
Yeah, maybe a quick comment on what we reported and what we find in the report. So we found that the topic of package hallucinations is not new, right? That has been around for some time. There are some good research papers around on this topic. What we found has not been investigated in more detail is the specific version recommendations done by such models, by those agents, right? So we wanted to know first of all, how important is this cutoff date for the training data of the underlying models in terms of the quality of the version recommendations, and how much improvement can be achieved when using tools, right? So this was the idea behind. And so we basically created thousands and thousands of kind of different prompts in order to let the agent recommend specific versions. And we found that without any tools, basically, to put it in a nutshell, only one out of 5 version recommendations were safe to use. There were very many hallucinated versions where it just imagined a Zenware version which just didn't exist on the respective registry. And we checked for like 5 ecosystems. And then also many vulnerable versions. And this showed that how much improvement can be achieved using tools, even generic tools that came with Cursor at the time we ran the tests. So we were not even yet using MCP tools in order to say, is this a known vulnerable version or not? But we relied on the built-in tools in Cursor, which were curl, for example, and grep. And when going through the conversation logs, we could see how Cursor would make an HTTP call to the registries, and then it would grab in the response to guess the name, which not always worked out. And it would also go to OSV and grab some JSON data, again, grabbing over the output to understand which version. And that is good. And this improved significantly the results. And we expect it will improve even more so if you use dedicated MCP servers that look at the specific, that have a proper vulnerability database and that are queried more efficiently compared to curl and grep, for example. And Amod, maybe you want to continue.
Oh, yeah, I think that's right. That's exactly right. I just wanted to take a step back and take an example. Let's say if you're trying to use AI to port a library from Python to Go, and the Python code that you're trying to port to Go it makes use of certain open source dependencies for which you don't have a corresponding version in Go. And let's say as part of this, the LLM hallucinates and tries to pull down a Go open source dependency that does an equivalent of what a Python dependency does. That in itself is okay, it's bad, but that in itself is not catastrophic. What is catastrophic is some malicious actor knowing that anyone attempting to do this will cause the AI to hallucinate in a certain way, and then pushing that non-existent package in Go with malicious code. So now you have a real package. LLM pulls it down. And if you don't have a tool like, let's say, Endor with its MCP server that can look at the packages and versions that are being pulled down to see what type of security is associated with that, then you're compromised. Having a hallucinated version breaks your build, something that doesn't exist. Having an hallucinated version that an attacker has anticipated and replaced with a malicious version on the package manager, that can cause catastrophic damage.
Yeah, it's a great distinction, as you said. One is just, breaks functionality. The other can compromise your organization. So definitely a big distinction to make there. And, I wanted to wrap up here, giving you a chance to kind of speak about some of the agentic AI security capabilities that Endor has been building Amod, because, I've been collaborating with the team there for several years. And early on, we focused a lot on open source software security, things like exploitability, exploitation probability, reachability analysis, things like that. And I feel like we've done a great job of keeping pace with the adoption of AI and agentic coding and things like that. So if you want to, you spend a couple of minutes talking about some of the features, capabilities that we've been rolling out to mitigate risk when it comes to AI, coding and things of that nature, to allow, again, to the earlier part of the conversation, allow security to leverage this technology and tool, just like our attacker adversaries are doing too.
Yeah, exactly. So we look at LLMs and agents as force multipliers. They can significantly augment your existing security capabilities. Endor has a belt of tools that can be used in different places. We started this company 3.5, 4 years ago, so we've had tools that predated AI. But what we've been doing consistently over the last 1 year is augment this capability at every step with AI. For example, we talked about the pair programmer concept. Right from the point where the code is conceived, you have an MCP server in Endor that you can use with your cursor, your IDE of choice, VS Code, whichever one you want, and it'll work as somebody looking over the shoulder of the coding assistant generating code. It'll catch security issues in your first-party code. It'll catch secrets. It'll catch malicious packages that you might be downloading, vulnerable packages that you might be downloading, and so on. If you put this SDLC view, as the code moves from the developer's workstation to your GitHub or your SCM pipeline, we will review the pull request. And the way we do it is we have these 3 agents that play different personas, one of the developer that writes the code, another of architect that knows about the entire system, and third of the AppSec engineer. And these 3 agents look at every pull request that's come down from any machine, any developer's workstation, and analyze them for security issues. So this is where we catch a lot of these authentication issues, authorization issues, business logic issues. And so we are not just looking for traditional SAST SCA type risks there. We are also looking for these higher order security issues. When we find them, we put them in, PR comments with a summary of what happened with a link to going into the Endor. Then as you go through the pipeline in your CI stage, we identify all the open source AI models that you might be using from Hugging Space or from Hugging Face or from other places. And we score them for security. We'll tell you if you can create a policy in Endor that breaks a build if a model that is not whitelisted is being used, or if a model that's disallowed is being used. So we have more deeper checks in the CI side. And then finally, for the findings that Endor creates, we have these AI assistants in the product UI. So if you're a new or a junior security person and you're going through a list of vulnerabilities and you come across something you don't understand, right there you can ask Endor what this means. How would an attacker exploit it? If you wanted to generate a test code against this, you could do it right in the product UI, copy paste it in your IDE, and see if that validates. So at different places in the product and different steps of the SDLC, we've tried to use AI to augment the workflow of application security engineers and software developers.
Yeah, I mean, this is the aspect of the team that I'm so excited about, is leveraging this technology. As you said, it's a tool for good or bad, right? And you know, as we kind of emphasized throughout the conversation, to keep pace with attackers, we should be looking to use this technology to become more efficient, more effective. You know, we've had long-standing workforce challenges in cybersecurity. The pace of exploitation is only accelerating. Like, we have to be trying to do these things, you know, to kind of keep up with the malicious actors. And again, you know, thank you both for jumping on, Henrik and Amod, for diving into all things dependency management, AI, agentic coding with me everywhere we went on the conversation. I'll put a link to the report for folks that want to check it out in the show notes, and hope you all have a great afternoon.
Thank you, Chris.
Thank you for having us. Bye.